Unit 8, Basic Plane Geometry. Geometry is a branch of mathematics that deals with points, lines, angles, planes, and shapes. Geometric figures form the basic shapes for parts you lay out and fabricate. When you lay out a part from a print, a fundamental knowledge of geometry is helpful. Excuse me. Figure 8.1 shows a large welded fabrication with many geometric shapes and angles. Plane figures. A plane figure is a flat figure with no depth. It is composed of straight or curved lines. Circles, triangles, and quadrilaterals are examples of plane figures. Circles. A circle is a geometric figure where all points on the circle are the same distance from the center. The following discussion describes some simple terms that apply to a circle. Figure 8-2 shows an example of the terms. Recognizing a chord, radius, and diameter of a circle helps a welder understand dimensions given on a print. The diameter is a line segment through the center of the circle having its endpoints on the circle. The radius is the distance from the center of the circle to any point on the circle, so its distance is 1/2 the diameter. A chord is a line having endpoints on the circle, but the line does not pass through the center of the circle. Often dimensions are given on a print as a diameter or radius rather than a linear distance. Figure 8-3. Interpreting dimensions given on a print often requires recognizing diameter or radius information rather than a linear distance. Circumference. The distance around a circle is called the circumference. It measures 360 degrees. The distance around a circle can be calculated using the circumference formula. A formula is a mathematical equation containing a fact, rule, or principle. When the diameter is known, use the simplified formula. Circumference equals pi times diameter, where C is circumference, that symbol is pi, 3.14, and diameter, or D equals diameter. Look at figure 8-4 for an example. To calculate the distance around the boss, multiply the diameter of the boss by pi. The weld distance is 1 inch in diameter times pi, or 3.14. Circumference equals pi times diameter, so 3.14 equals 3.14 times 1. Because the diameter equals twice the radius, another formula for circumference is, excuse me, circumference equals 2 times pi times r, where circumference C is circumference, 2 is constant, pi is 3.14, and r is radius. Circumference, radius, and diameter are all measured in the same units. Arcs. Figure 8.5 shows a round part with multiple welds. Estimating the amount of electrode needed to complete the weld requires determining the circumference. An arc is a portion of the circumference. If only a portion of the distance around the boss requires welding, the distance is usually given in degrees. Figure 8-6 shows an example of welding required around only part of the boss. Sometimes only a portion of the distance around the boss requires welding. The arc length is calculated by first determining what part of the 360-degree circle consists of the 70-degree arc. To determine this, divide 70 degrees by 360. The decimal that results is then multiplied by the circumference. For example, arc length decimal equals length of arc divided by 360 degrees. So 0.19 equals 60 degrees divided by 360 degrees. Arc length equals arc decimal times circumference. 0.06 inches equals 0.19 times pi, 3.14. Area of a circle. Area is a number of unit squares equal to the entire surface measure of an object. The formula for circular area is area equals pi times r squared, where a is area, pi is 3.14, and r squared is radius squared. Remember, the order of mathematics operations is important for this calculation. You need to complete the exponents or powers first, followed by the multiplication and division, and then addition and subtraction. For example, if the circular area of a surface welded section on a wheel loader bucket is needed to determine the amount of required welding electrode, then first the radius of the section needs to be determined. Figure 8-7 shows a wheel loader bucket with a circular section marked. If the diameter of this area is 10 inches, then the radius is equal to 5 inches. Calculate the area by squaring the radius and then multiplying the square of the radius by pi. The area calculation is used to estimate the amount of electrode needed to surface the area or to determine the extra weight added to the bucket. For example, area equals pi times radius squared. Area equals pi times 5 times 5. Area equals 3.14 times 25. Area is 78.5 inches squared. Angular measurement. Did you notice that the distance around the circle might be given in degrees? Angles are also measured in degrees. An angle is the intersection of two lines or sides. Many of the parts you will lay out and fabricate are not long straight lines, but are at some angle to each other. Figure 8.8 shows a large weldment with many angles. Since weldments often consist of many angle surfaces, it's important to know how to measure angles. To lay out angles or to determine missing angular dimensions on a print, you need to know a few common types of angles. Figure 8-9 shows the angular measurement for common angles. A straight angle forms a straight line and measures 180 degrees. A right angle is formed when two lines intersect perpendicular to each other. A right angle is always 90 degrees. An acute angle measures less than 90 degrees, and an obtuse angle measures more than 90 degrees. Half a circle and a straight line measure 180. The two angles that form complementary angles have a sum of 90. Most common measures are shown. Right angle, obtuse more than 90, acute less than 90. The angular measurement for a straight line is 180 degrees. For a right angle, the angular measurement is 90 degrees. Notice that the two right angles form a straight line. For the right angle, the sum of the angles that form the right angle is always 90 degrees. Figure 8-10 shows the angular measurement of a straight line to a circle. Half of the circle measures 180 degrees, so does a straight line. In figure 8-11, angle A is called the complement of a 30 degree angle. Complementary angles are two angles formed by three lines with the sum of the angles equal to 90 degrees. For these complementary angles, angle A is equal to 60 degrees. 90 degrees minus 30 degrees equals 60 degrees. If the two angles combine to form a straight line, then the angles are called supplementary angles. The sum of the angles that form the straight line is 180 degrees. Figure 8-12 shows the example. Angle B is equal to 50 degrees. 180 degrees minus 130 degrees equals 50 degrees. Angles on prints. Look at figure 8-13. A detailer provided dimensions for this subassembly to be welded, component and angular measurement. However, the boss prevents you from laying out the angle using the 35-degree angle. You need to calculate the supplement to locate the angled part. Remember, the sum of the supplementary angles is 180 degrees. For the part in 8-13, the angle needed is calculated by 180 degrees minus 135, which equals 45. The supplementary angle must be calculated to locate the angled part. Triangles. Triangles are three-sided figures with three interior angles. Triangles can be formed on prints to help calculate missing dimensions. Figure 8-14 shows a right triangle, which is a triangle with one 90-degree angle. The two sides that form a right triangle, side A and side B, are called legs. Fillet welds use the same term, leg, for the vertical and horizontal parts of the weld. The side opposite the right triangle is called the hypotenuse. For triangles, the sum of the interior angles is always equal to 180 degrees. For example, figure 8-15, the angle formed between leg A and the hypotenuse C is 25 degrees. The angle formed between leg B and the hypotenuse C is calculated by the first subtracting the right triangle or right angle 90 degrees from the sum of the angles of a triangle 180 degrees. So 180 minus 90 equals 90 degrees. Then subtract 25 degrees from 90 to determine the angle BC. So 90 degrees minus 25 equals 65. Area of a triangle. The formula for finding the area of a triangle is area equals half base times height, where A equals area, half equals constant, B equals base, and H equals height. For example, the area of a triangle with a 5-inch base and a 10-foot or 10-inch height would be area equals 1/2 BH. Area equals 1/2 times 5 times 10, so area equals 25 inches squared. Pythagorean theorem. A theorem is a mathematical truth that can be proven if only two sides of a right triangle are given. The third side can be found using the Pythagorean theorem. The theorem states that the square of the hypotenuse is equal to the sum of the squares of the two legs. The equation of the Pythagorean theorem is c squared equals b squared plus c squared equals a squared plus b squared, where c squared is the length of the hypotenuse squared, a squared is the length of one side squared, b squared is the length of the other side squared. Refer to figure 8-16. The third side of a right triangle can be found by using the Pythagorean theorem. If the length of the hypotenuse in 8-16 is needed, then the length is calculated by first squaring side A and side B. To complete the calculation, the squares of side A and B are added together and the square root is taken. The square root of a positive number, x over or times the square root of x, is the positive number n such that n squared equals x. In equation form, the theorem is c equals a squared plus b squared, the square root. Referring to figure 8-16, c squared equals 5.5 squared plus 3 squared. C squared equals 30 1/4 plus 9. C squared equals 39.25, or 39 the square root of 39.25, which is 6.26. Figure 8-17 shows a gusset triangular support on a T-joint. The detailer has provided the length of the hypotenuse and one of the leg lengths, but to fabricate the gusset, it would be easier to use the length of the two legs positioned at a 90. To calculate the missing dimension, the Pythagorean theorem needs to be algebraically manipulated, beginning with the equation c squared equals a squared plus b squared. C squared is 8.5 equals 3.2 plus b squared. 72.25 minus 9.73 equals b squared. 62.52 equals b squared. The square root of 62.52 is 7.91. Parallel lines and interior angles. A useful geometry rule is shown in figure 18 or 8-18. An auxiliary line helps visualize the relationship between lines and angles. Notice that an auxiliary line is drawn parallel, non-intersecting, but the same distance apart at any location, to the extension line containing the 20-degree angular dimension. An auxiliary line is an additional line used to help you visualize the relationship between lines and angles. You will usually sketch an auxiliary line parallel or perpendicular, forming right angles to existing lines and features on the print. A geometry rule states that if a diagonal line intersects two parallel lines, then the opposite interior angles are equal. Therefore, if a 20-degree angle is known, then the angle A is also 20 degrees. Using the two previous concepts, angle B in figure 8-18 can be calculated. Use a second auxiliary line drawn perpendicular to the first auxiliary line. Connect it to the point where the angled line begins and the right angle is formed. The sum of the interior angles of a triangle is 180 degrees. The angular measurement of the right angle is 90 degrees. Therefore, angle B is equal to 70 degrees.